Good evening, ladies and gentlemen. Thank you for joining us tonight. The lecture will begin at 6:30, so we'll get started in 10 minutes. Good evening, ladies and gentlemen. Thank you for joining us tonight. The lecture will begin at 6:30, so we'll get started in 5 minutes. It's now 6:30 p.m., so let's get started. Ladies and gentlemen, please help me welcome the Executive Director of the Natural History Museum of Utah, Dr. Jason Cryan.
Good evening. I'm Jason Cryan, the Executive Director of the Natural History Museum of Utah. The mission of our museum is to illuminate the natural world and the place of humans within it. And so tonight, I welcome you as we gather virtually to find inspiration in the experiences and insights of scientific luminaries in our 2021 lecture series, Trailblazing Women in Science. Before we begin, I'd like to recognize the museum's sponsors and partners whose generous support makes this lecture series possible. We're particularly grateful to our founding underwriter, the R. Harold Burton Foundation, and our underwriter, the Cultural Vision Fund, for their tremendous and ongoing support of this series. We'd like to thank our gold sponsor, Rio Tinto Kennecott, and our silver sponsors, the Clark Foundation, the DeFiore Foundation, the M. Lazy M Foundation, the Nature Conservancy in Utah, Ruth Novak, and Paula Swanner Sargetakis and Joseph Sargetakis of Frog Bench Farms. And we're also grateful to our community partner, Liberty Heights Fresh. Finally, many thanks to the voters of Salt Lake County. Their approval of the Zoo Arts and Parks Fund provides invaluable support for wonderful programs, both here at our museum and throughout Salt Lake County. So please join me in thanking these incredible partners and supporters. The format for this 2021 lecture series is just a bit different from previous years. This year, each guest will speak for about 20 to 30 minutes, after which I'll join her for a conversation. And finally, our speaker will field some questions from you, our audience. So let's get to it. There are many words that one could use to describe our special guests this year: pioneers, innovators, and trailblazers. For this series, we define a trailblazer as someone who's taken risks to create a path that wasn't already there. Their insatiable curiosity and their irresistible drive impelled them to pursue careers that had not been pursued before by others like them. They were the first. They were the forerunners. They risked much, and their efforts resulted in remarkable success. Our speakers boldly follow their passions, and they make significant contributions to their field. And importantly, they not only break barriers that allow others to follow their similar paths, but they also inspire others to follow those paths, serving as role models for generations to come. Next Thursday, April 15th, we're excited to have the University of Utah's own Dr. Nalini Nadkarni, a trailblazing forest canopy ecologist who continues her pioneering efforts just now by bringing science education to the incarcerated. And we're eagerly anticipating our keynote speaker, Mae Jemison, on Thursday, April 22nd. Dr. Jemison's a true trailblazer with a remarkable career filled with adventure and exploration, including being the first woman of color in space. And we hope that you'll join us for those two exciting evenings. But tonight, we're thrilled to welcome a trailblazer in technology and STEM education. Ayah Bdeir is an inventor and entrepreneur who founded LittleBits Electronics, which is a company that produces snap-together electronic module kits that teach kids about electronics and engineering while promoting gender neutrality in toys and inspiring boys and girls to consider careers in engineering. So please join me in welcoming Ayah Bdeir.
Thank you so much for having me, Jason. Thank you to the Natural History Museum of Utah for organizing this lecture series. I'm really humbled to be in the company of the other speakers that are in the series. Today, I'm going to be talking a bit about some new thoughts that I've had over the past year, some research, some thinking that I've had after having sold LittleBits in late 2019, and really had the opportunity to zoom out a bit and think about the world ahead. Obviously, the pandemic that we went through was an existential event, and the silver lining, despite all the downsides of an event like that, is that we get to think about the future and be a little bit more deliberate about how we're going to participate in it. So these are some thoughts about what I've been thinking about, and I'm looking forward to getting feedback and hearing views from the audience and chatting with you further, Jason. So let me go ahead and share my screen. I think I need to have screen sharing from the Zoom. Oh, there we go. All right. So tonight I'd like to talk to you about the building blocks of the future. I'm a little bit obsessed with the concept of building blocks. Modularity is something that I have spent the last 10 years thinking about. But in this talk, I'm really thinking about it in a bigger way and really trying to sort of reassess how to evaluate the future with this concept in mind. So to start, I'm Ayah. I've already said this. I want to start with a few headlines that I've collected over the past couple of years. I believe that we have gotten to a point where we don't understand the world we live in anymore. The social, governmental, technological structures we have built have become really complex and seem to have developed a life of their own. And we're almost passersby in this life trying to make sense of what's going on. We relearn fundamentals of life, of our world, when a crisis happens. We learn about our immune system when the COVID-19 pandemic starts. We learn about the financial system when the financial system collapses in 2008. We learn about the human body when we get a bad diagnosis from a doctor. We very basics of nutrition, of how our body works, are things that we don't understand. Even recently, for myself, I learned about women's reproductive cycles just because my husband and I are trying to have a baby. So these are events that happen that cause us to have to learn things that I think should be fundamental and should be basic. And when we are learning in this defensive mode, it becomes about unlearning. It becomes about catching up. It becomes about really changing habits. And I believe that can be really difficult. So the past year that we have lived through is really an opportunity to say, let's take a pause and let's look at the world that we are in. Do we really understand the world we're living in? Can we fix what we do not understand? Is this an opportunity to reinvent the future, do things differently, fix things that we know have not been working for everybody? And if we do embark on this reinvention, will everyone participate in this reinvention? How will we make sure that this is going to be as inclusive an effort as possible? Today, I propose to do just that, to take a pause and look ahead and think about what are the most important topics for the future. What are the most important fields? What are the most important questions? And can we really tackle them and break down this complexity that we are faced with? I propose to adopt a design principle, which is modularity, in order to address this complexity. And that process really kind of breaks down into 3 steps. Number 1, break it down. Number 2, understand it. And number 3, reinvent it. This is something that I can talk about, in specific with my experience with littleBits, but I think can apply to fields outside of electronics and to any field that you can think of. I think if we're able to break down these fields of the future, understand them, and reinvent them, we can do that better, we can do it more inclusively, and we can do it more harmoniously. So let's start with the basics. So what does modularity mean? Modularity, at its most basic definition, is this idea of building a complex product from smaller subsystems that can be designed independently, but also function together as a whole. The best example of modularity is obviously this Lego system. I don't think I need to introduce Lego to anybody, but as many of you may know, the first Lego brick was created in about 1949, and since then has become one of the most extensive modular systems in the world. The design rules are relatively simple. There's a standard stud size, there's a standard multiple of each brick in terms of dimension, there's a standard measurement between the studs, and from those design rules, there are thousands and thousands of parts that can fit together. What this allows us to do is, at a basic level, it allows us to understand architecture better. It allows us to create buildings and structures that are more complex that we may have not understood if we had tackled it without this modular system at the base. And so this is an example of a structure that's been designed with Lego bricks, thousands of them. But you can imagine a kid or an adult building one brick at a time from really having no background in architecture whatsoever, no background in civil engineering, but being able to build up from there. So that's sort of the idea. Can you use modularity as a way to break down these systems and these fields ahead and kind of adapt it? We know that modularities existed across industry, transportation, computers, construction, thousands of other fields historically have benefited from modularity in reducing costs, in increasing speed, and in accelerating innovation. But what I'm proposing today is to, like I said, use it to reinvent the world. So Jason mentioned this at the beginning when talking about littleBits. I've already actually done this. I've done this in the field of electronics in particular. My background is in engineering. I have a background in computer engineering from the American University of Beirut, where I'm from, and I have a master's in electrical engineering from MIT. And I studied engineering for a long time, and really found engineering to be quite boring. Particularly in my undergrad, I found it to be boring. I found it to be dry. What you see here is the Z80 processor, which was the first processor we learned in computer engineering class. This big behemoth of a piece of electronics that was really obscure, really opaque, and really difficult to understand. And so many years later, I asked myself, can we make electronics more creative? Can we make them more fun? Can we make them more inclusive? And so I embarked on this idea, this prototype that I later called littleBits. The premise was that technology is too pervasive. Electronics are everywhere. We spend 10, 12 hours a day with our technological devices, and most of us don't understand how they work or how to make our own. So can we create a toolkit? Can we create a set of building blocks to allow anybody, people that are not engineers, to be able to participate in this creative process with electronics? What you see here are the early prototypes of littleBits. They are these individual modules on the left, the early drawings of what this concept could be if you break up a circuit into individual modules that then are interchangeable and interact together. On the right is the first such prototype with a battery in it that then, many generations later became what you see on the screen here. Ultimately, the littleBit system became a system of these electronic building blocks that are color-coded, 4 colors. Blue is power, pink is input, green is output, and orange is wire. And through this very simple color code and simple design rules around size and electronic specifications, you're able to essentially create thousands. In this case, we did over 70 different modules that represent technology around the world: lights, sound, sensors, motors, fans, solar panels, speakers, anything that you can think of that you perceive around the world can become this building block that you can then interact with. And so this is sort of this idea of breaking down something complex like the field of electronics into these building blocks, and then giving these building blocks, in our case, we gave them to kids, we gave them to designers, to artists, we gave them to non-engineers, and we started to look at to see what they did with them. And so I'd like to show you a video. So as you can see, we've had kids inventing anything from bubble blowers to Ferris wheels to robots to all sorts of devices. And really the essence and at the root of it is this idea of these building blocks. What you see up on the screen now is what it would take if you broke up a light bulb. That would be a power bit and an LED bit. Next up, you add up in complexity. What does a nightlight look like? A nightlight has a switch and a light sensor, also has an LED. And so now you're creating a little bit more intelligence in this device. Next up, we have this thermostat. In this thermostat, we have a temperature sensor. We have a number display, numeric display. And then if you wanted to create an internet connected thermostat, like a Nest, that would be more complex. You would add a little bit more programmability. You would add internet connectivity, like with a cloud bit. You potentially could add a motor to be able to activate things. But you're able to build one step at a time. You build from something very simple. You build up in complexity as you need it. It becomes understandable. It becomes fathomable. It becomes something that is empowering. It is not scary, it is not complex, and it is not something that is just limited to the elites or to engineers that have many years of experience. What was really exciting when we launched this, I launched this in 2011 as a company, and we went to schools, we went to kids around the world, homes, and we would see kids come up with all these very intelligent questions about the world. What keeps an elevator door open? What does sound look like? What is the Internet of Things? They were asking questions about the world around them, and this allowed them to understand what the world was made of or how it functioned. And then it allowed them to participate in it. Some of these pictures that you see here are some of the inventors that we met throughout the years at LittleBit. So here you have some students from a school in New York City called Marymount. They've created something called the Aerocast 3000. For one of the students, her brother broke his arm and had a cast and was always complaining about how hot the cast was, and he wanted to scratch an itch. And so she made him a little motorized robotic scratcher so that he could have a little fan and have a little more air and also scratch his itch when he wanted with a little button and stop complaining. We have here another one of our inventors, Vedant, who created a new type of sport. He called it pin golf. It was a merger between pinball and golf. And it was also wirelessly activated. So on the left side, you see he has a little, I actually don't know what the name of the golf golf club. And when he knocks a ball over on the pinball side, a ball goes in the hole. And so he invented a new game. Here you have two sisters. The eldest one is called Anahit, who invented something called bat vision, which is she wanted to help her grandfather, who had vision impairment, navigate around the house. And she was inspired by how bats are able to identify spaces, and created this little device so that he could navigate. And so you could see a different kind of inventor participating in this process. You see more girls, which are typically excluded from STEM fields and engineering fields. You see kids that have different learning abilities, kids that are neurodivergent, kids that are not classically the best students in class are participating. And so you really are able to kind of see a different kind of fresh take at this kind of innovation. This worked across different fields. It worked when we worked on science with NASA. It worked when we worked on more design applications with the design store. We did programs with Disney. All of this is an idea that can apply whatever field you're in. And so that was really emboldening. littleBits was acquired in late 2019 by a company, Sphero, that's an education technology company that continues this mission and continues to really create tools for the next generation inventors. And it's something that is constantly really inspiring to see. And so how do we take this kind of model, this template? After sort of I finished that first chapter of my journey, I got a little addiction to this idea. How can you create more building blocks? How can you create the building blocks of the future? Can you use this method to apply it to the rest of the world? In this case, I'm picking specific examples. that I think are relevant, and I think that we misunderstand, and many of us don't understand at all. Where we live, how we eat, what we eat, the tech we build, or how we make. These are 4 simple questions. In this case, I decided to pick questions about the world instead of fields, so that we can really make it more human and make it more understandable to everybody. In designing, in kind of approaching this, there's sort of the classic way that a modular system is evaluated. Usually we'll evaluate a modular system by technical terms: level of abstraction, recombinability, expandability, etc. These are ways that when you're an engineer, a designer, when you're a manufacturer and you're evaluating a modular system, you would evaluate the building blocks this way. What I'm proposing for this new future building block is a different set, or an additional set of criteria that are more human, that more sort of reflect the kinds of inventions we want to see in the world. Legibility, can I understand it? Agency, can I create with it? Impact, is it important for the future? And risk, is there a danger if this was not done? And so these are some thoughts I'm having about how to evaluate building blocks of the future and sort of deciding what to embark on. So with that, I'll show you some of my favorites. These are just examples. There are dozens and dozens of others that are out in the world, but these are not my projects. These are by other designers, architects, engineers, companies that are out there, but I just find really inspiring. To answer the first question, where we live, how can we understand better where we live? How can we reinvent where we live in a way that is more harmonious and more equitable and better? What I show here is a project by David Benjamin, architect, winner of the MoMA Young Architect Program in 2014. It's called bioengineering bricks. The brick in this case is made up of agricultural waste and fungi. It's a bioengineered brick that is manufactured, that starts from corn stalks and living mycelium roots, and really is a very organic brick that has been formed through various levels of adjustments in the way it's manufactured. And so what it allows you to do is create these structures, these huge structures, these buildings. In this case, this was the pavilion at MoMA, made of natural material, and a material that will decompose and go back to earth and not produce any extra waste, as you can see here. So you can see how this new building block is a better building block, and is an interesting way to think about architecture, and really allows us also to understand where we live and the buildings that we make. Another example I want to show is something that's actually really dear to me, is about what we eat. I had never cooked in my life when the pandemic hit. I'm lucky to have a husband that's a really good cook. When I was growing up, my family, multiple people were really good cooks, so I never had to. And then when the pandemic hit, I said, okay, now I have to figure this out. And it was really overwhelming for me, because I couldn't understand. I knew what good food tastes, I know what good food tastes like. I know what I like, but I never know how to make something that's not good better. I don't know how to start, not from a recipe, until I saw this book and a Netflix series by chef Samin Nosrat called Salt, Fat, Acid, Heat. This system that Samin Nosrat created is a revolutionary, this is from the description, revolutionary yet simple philosophy. She essentially divided food into 4 elements: salt, that enhances flavor; fat, which delivers flavor and generates texture; acid, which balances flavor; and then heat, which ultimately determines the texture of food and anything you want to of food. With those building blocks, with this sort of ability to understand food better, you can create the most delicious food. So this is a really famous drawing that she has in her book that essentially allows you to think about what you want to cook through these 4 pillars: salt, fat, acid, heat. And now you're able to really prepare something delicious, not knowing anything. And what I really love is a description in the book where she says, You can prepare something delicious using just about any ingredient without even following a recipe. In a sense, you cannot make cooking any more democratic than that. This is what we're talking about here. Reinventing the world, reinventing the future means more people should be involved, means creating a democratic process for people to be involved in. And this is what Samin Nasrat has done here. This is sort of specifically how you would apply it to creating a salad and really being able to add complexity. Like I mentioned before, with littleBits projects, you add complexity from the ground up. We're talking about the same thing in the context of food. Another example I really love is Scratch. This is really thinking about the tech we build. I think the past couple of years have shown us how important technology is in our lives, how much it governs everything we do, how software that is written badly, or how programs or products that are not made well really can affect our daily life and really cause a lot of problems. Scratch is a platform, a free programming language for kids to learn programming. And it is based on a modular system where you have these building blocks that attach together, that are reconfigurable and allow you, without any experience in software programming whatsoever, to start building programs that are more and more sophisticated. And when you do that, there's over 80 million projects on Scratch, over 10 million people, 20 million, I think, 30 million creators. Many of them kids from all backgrounds, from all ethnicities, all ages. And what you see, the projects that they create, it's really inspiring. This is a little video, I'm not going to play it, but when the Black Lives Matter movement started, kids rallied to start to create these projects, animations, games, various platforms to respond to Black Lives Matter, to show that they cared, and they collaborated on them. And so you see this sort of the agency that they feel, and this ability, this empowerment that they feel, and their ability to use technology to express themselves. And then the last modular system I'll talk about today is the open source ecology system. So this is created by engineer Marcin Jakubowski, who created the Global Village construction set. He calls it a life-size Lego set of powerful self-replicating production tools for distributed production. What he's saying is that if you wanted to start a civilization from scratch and you wanted modern-like living in the civilization, what are the set of tools or machines that you would need? And he came up with 50 machines that are modular, that are interchangeable, and that work together to be able to create this system of tools that allow you to build a civilization. These are some of the pictures, some of the machines that you see, tackling anything from energy to food to production. And then this is an example of it applied to, for example, created an expandable, what they call an expandable starter home that is made much more harmoniously with nature, that utilizes energy in a much better way, and that really kind of combines together. So the question is, can we use this way of thinking? Can we use modularity? Can we use the system of building blocks to answer every important question in the world? How we learn. One example could be Netflix Explained, which I don't know if people are familiar. It's this show with like really snippets, videos about important topics that I find to have some elements of modularity that are really interesting. Could be a way to think about the future of learning. Who we are. Can we learn more about psychology, about personalities, through adopting more pervasively the Myers-Briggs system that really kind of helps modularize the way we think about people? What we're made of, DNA, CRISPR is another example. So these are just some thoughts that I've started to put together. There are dozens of others, but the idea is that, can you answer every question through this kind of thinking? Can we take a look at these big complex questions? Can we break them down? Can we understand them? And can we reinvent them this time better? My hypothesis is that when we create the building blocks for everyone to invent the future, they will. I plan to dig a little deeper into this question. I'm looking forward to hearing any thoughts or reactions on this idea, and hopefully be able to invent the future that we want to live in. Thank you so much. Jason, over to you.
Thank you so much, Ayah. That was really fascinating. I appreciate so much your perspectives and your experience with this. One of the great things of our modified online format now is that I get to spend a little time with you asking questions and having a conversation before we delve into some audience questions. While we do that, I'll just remind our audience that if you do have questions and you'd like to submit that question for Ayah to answer, you can do it in one of two ways. You can, if you have a YouTube account, you may submit your question as a YouTube comment. And if you don't have a YouTube account, please click on the link that we've posted in the comments and it will take you to a web form. And you can submit your question via web form. So while we look for some audience comments and questions, let me delve in. So this is really fascinating to me, and I have so many questions for you myself. The first is, you've mentioned a couple times that littleBits and your work with the modular systems have promoted innovation and engineering skills and learning in both boys and girls. Can you talk a little bit more about gender neutrality in toys and how that's promoting STEM career choice?
So I was a geeky kid. I was a tinkerer kid. I was always taking things apart. I naturally sort of gravitated towards engineering when I was younger. And my parents and my teachers encouraged me to do that. But when I went into engineering school, there were so few women. And I started to become more and more and realize more and more how really insular the field of engineering is and how low representation there are for women and minorities in general. And so that was something that was really kind of both an experience that I felt and almost a mission that started to form. When I started thinking about littleBits, one of the core principles was that this was going to be more open and inviting to everyone, to non-engineers, to girls, to boys, to kids that don't think of themselves as technological, to people that say, I'm not a techie or I'm not creative. I wanted that to be inviting to them. And so one of the early design principles of littleBits was gender neutrality and was universality, that it had to work across languages and it also had to be gender neutral. And so the colors of littleBits, you see they're candy colored. The circuits are white so that they don't sort of attach to the stigma of electronics, which are usually black or green. The projects we showcase were always things that were, sibling alarms or I mentioned before, Ferris wheels, not necessarily cars and not necessarily sort of shooting games. And so it was a very deliberate effort to do that. We had to make this case with the toy industry, where usually you'd have a pink aisle and a blue aisle. We'd had to make this case with schools. We had to make this case with parents. We had to really work very hard to introduce this idea of gender neutrality. This was 2011, so this idea was really foreign at the time. But I'm really pleased to say that the thinking around this topic has really changed and industry has shifted, and there's a lot more embracing of this topic and a lot more kind of vocal efforts toward getting more girls and minorities into STEM in particular, because it's such an important field.
That's amazing. And so are you actually seeing young girls embrace this technology and start seeing themselves in these important technology careers? Absolutely.
We see, the littleBits community was consistently between 35 and 40% girls. This is astronomical if you compare it to sort of other kinds of technology tools or electronic tools. Lego robotics was around 10% girls, for example. So we saw that definitely. The unfortunate thing is that it's not enough to address it with kids at the age 8 to 12. That's a big cliff where kids start dropping off in their interest. But you then have other cliffs that are in early career, when they go to university, when they go into the workplace and they face discrimination. So we made a lot of impact at the age group that we were focused on. But really, there's a lot more focus that has to happen in a global sense to be able to solve the problem of minorities and women in STEM as a global thing.
Interesting. During your talk, you mentioned that you prototyped littleBits with kids and with non-engineer. Do you see a difference in what the children are making with littleBits versus what adults perhaps would make?
It was interesting. I loved seeing that. Kids invented things that solved important problems. Sometimes they were important problems for their families or their friends. Sometimes they were important problems for society and humanity. So we saw kids making anti-bullying alarms. We saw kids making environmental, for example, waste management solutions. We saw kids making assistive technology. They made wheelchairs that have different buzzers and lights to allow somebody in a wheelchair to be able to move in a better way. A lot of times it was about humanizing people around their lives that had certain difficulties in integrating society. Adults typically will recreate things that exist. They recreate things like a plant feeder or a remote controlled or internet controlled doorbell. Fun, good stuff. I'm not here to judge what people invent, but I was always more inspired by what the kids made because they always had a mission. This generation is a generation of activists, and it's always so exciting to see.
That's a really interesting observation, that children are perhaps more creative than our adult
Absolutely.
counterparts. Hey, I'm really intrigued by the guiding challenge that you seem to live your life by, and that is breaking something down, understanding it, and then reinventing it. And you've talked a little bit about how that set of principles could be applied to non-engineering fields, other parts of life. But what are the kind of modular problems that you see in other fields that this could be applied to?
I think psychology is really interesting to me because I think this is a field. I don't think humans understand humans very well. And I would like to figure out ways that we can kind of break basics of human nature and psychology up into ways that we can understand it better so we can interact with each other better. The example I gave, I went over really quickly, was the Myers-Briggs system, which is an interesting system. It's not the perfect system, modular system to use. It does help you understand personality types. I don't think it kind of allows for the reconfigurability in the same way to be able to show us the complexity of human interaction. But that's something that I find really interesting. The future of education, I find really interesting. I'm really inspired by, I mentioned Netflix Explained. I love their little, really well, self-contained videos about a certain topic, and they really cover them from a 360 angle, from the technology, the social impact, the problems, the criticism, the pros and cons, etc. I find them really interesting units, and I wonder if you can create these kinds of systems where they can interact with each other. I think TikTok, the way TikTok is used for learning, is really interesting too. It's these like people that are non-educators, that are not experts, that are coming up with their little TikTok snippets that are tackling subjects and doing a much better job explaining history and explaining physics than some of the best professors. And so that's another one that I'm really intrigued by. Things around the financial industry, I'm really intrigued by, like, how do you understand the financial systems better? Like, is it something that's more around kind of the blockchain and how that interacts with the financial system, or could it be something that's more specific? So these are some things that I'm kind of thinking about, but I do think that you can apply this sort of way of thinking to any field that is important for us to understand in the future.
That's a great idea. I think that it would be so interesting to be able to break down our common problems to manageable units, so that we could kind of figure out what the best course forward is for these, for the solutions. It's intriguing. I have just one more question for you, and then we'll dive into some questions from our audience, if that's fine. You have mentioned that this past year of COVID has kind of represented a unique opportunity for us to start reinventing the world and start reshaping how we think. So what is it about this particular moment in time that makes you think it's the right time?
I mean, this has been longer than a year, I would say. It's been decades and decades in the making, but I think that the pandemic shone a spotlight on problems we've already had. first of all, it sort of stopped us all in our tracks and sort of made us feel that, the way we've been living is not sustainable and we have to do things differently. It's not sustainable towards the environment. It's not sustainable towards our health. It's not sustainable towards, the way we interact with each other. And that was kind of like the first layer. But then the second layer was that it's shown a spotlight on a lot of inequities in the world that I think many of us were not taking seriously enough. Racial inequities, and of course that also ties to a lot of the racial sort of movements that have been happening. Economic disparities, social disparities around how much women were more affected during the pandemic and during all the sort of education requirements around and home care, etc. So it really shone a light on on all of these problems that we've had and we've somewhat ignored. And I think with that problem comes an opportunity. We cannot continue living the way we have been living. We have to do things differently. It is our responsibility to address these inequities. It is our responsibility as technology creators, as scientists, as communicators, as thought leaders to espouse a different way of thinking. And I believe the first step in it is really to understand what is going on and then sort of equip not just ourselves, but everybody with the tools to be able to reinvent it because they know best what they're experiencing. So I really would like to see us really take advantage of this moment to be able to redress these disparities.
Thank you very much. So let's dive into some questions from our audience, and we have many. So I'm going to go through some of them as we can. I'd like to start with this one by Katie here in Salt Lake City, and I'm going to read it verbatim. So Katie asks, I'm a female engineering student and I struggle a lot with self-doubt and feeling like I don't belong in this male-dominated field. So did you ever experience these feelings? And if so, how did you overcome them?
I absolutely experienced this. I can very much relate. I still experience it. There are studies that have shown that the imposter syndrome is something that is more felt within women than within men. It's something that's very real. We are often ashamed to talk about it. We think we're not good enough. We think that we are not as qualified as others in the room. We think that we're imposters. And I think, the only thing that helps in this case is to talk about it and is for others who feel the same way to talk about how they feel that way as well. And really to start looking at the research and seeing that the research is proving this point over and over. We're seeing that there are actually disparities in how women and men are evaluated in technical fields. Some research that shows that the same CV applies to a job when there's a male name and a female name on the same CV. The male names tend to get hired at a higher rate. So there are actual problems. It's not just in our heads. So it's not that we have this imposter syndrome in our head and we have to work on ourselves. It also reflects the way the world works. So we have to work on both sides. On one side, knowing that we're not alone, that this is something that we are conditioned and self-perpetuating. But even more importantly, this is something that's happening actually in the world that we must fix in the workplace, in the education system, in society, and in our own homes.
So I'm going to follow that up with another question by Max, who's asking, why is 10 years old such a critical age for young women? You've mentioned that kids, have these drop-offs. So why is that such a critical age for girls in science and STEM?
So I'm glad you asked this question. At a young age, around 4, 5, 6, girls and boys are equally interested in science and engineering and math. And then the numbers start to drop around age 8 to 12. For different kids, it's different, but age to 12, there's a really big cliff where girls and boys start looking differently at STEM, and girls start dropping off in their interest. And it's a combination of many things. One of them is they have no role models to look at. So they don't see women that are leaders in STEM that they aspire to be. The inventors they read about, the scientists they read about, they're always men. So they, are not seeing themselves in the future. They also are getting many times bullied in classrooms. If you're doing coding camps, if you're doing science classes, there are more boys. A lot of times it's not a well requirement for them. They also are told by society that it's more important for them to be beautiful. It's more important for them to be sociable. It's more important for them to find a mate. It's all these things are being absorbed by girls. And so they are starting to drop off in their interest. And I think it's not because they're not interested or not good at it. On the contrary, I think it's because they think it's not for them. There's another big cliff that happens, in early career when women start experiencing different kinds of discrimination and harassment in the workplace. Then there's another cliff that happens in early family life when the burden of family care starts to fall on women and they start to prioritize family over it. And so these are big cliffs, but the 10 to 12, the 8 to 12 segment is pretty important, because if you don't solve it at that point, it's very difficult to recover from it after.
Thank you. Let's skip down to a question by Mark here in Salt Lake. And Mark is asking, first says, great talk. How do you see applying the ideas of modularity to the process of education itself, primary and secondary schools, universities, later learning?
I think there are a lot of elements of modularity in education already. The concept of modules, courses, a lot of curriculum is designed somewhat modularly. I don't think that it's as effective when you start really thinking about mixing and matching, and when you think about kind of designing different paths that are reconfigurable depending on what students have affinities towards. There are more and more of these programs. When you look at things like micro-credentialing platforms, when you look at things like, the online learning platforms or the online courses platforms like Khan Academy, others, it does have a little bit more of that element. But I don't think there's any holistic system that really does a good job of really leveraging the benefits of modularity towards education. I mentioned before the way, TikTok, I think potentially TikTok, Instagram, you have these little tools that are being used by educators really effectively. I'd like to see more research around that and more kind of trying to push that idea further to see how we can make it into something as powerful as a Lego brick becoming a spaceship, for example.
Excellent. Very good. Joan Ogden here in Salt Lake doesn't have a question, but she just says, what a wonderful presentation. Thanks.
What a lovely note. Thank you so much, Joan.
So let's see. There's a question by Race who asks, how do you begin the process of breaking down a subject or a structure into modules? So what are the first steps as you're approaching a new problem or a new area?
So this is a great question. I think it does take a little bit of understanding of what modularity means. I spoke a little quickly when we went to kind of some of the technical sort of aspects of modularity, but I do think it's important to understand them. Level of abstraction is an important concept. It's this idea of how granular do you have to get on a module to have enough understanding of it, but not too much complexity. That's something that's important to, I think, understand a little bit more. There's this idea of called information hiding in modularity, which is this idea that a module inside of it can have lots of properties that are very unique to it, but its interface with other modules needs to be standard. So for example, if you think of a Lego brick, a Lego brick on the inside could potentially have water in it, or could be made of sand, who knows? But as long as it respects the sort of outside interface, it could still fit within the system. So some of these technical concepts are important to understand, and they're very widely available. This is not kind of special science. But then what I would say is kind of when you look at the topic that you're trying to break down, the first thing I would do is try to catalog. Sort of just like, it's kind of the Marie Kondo method, I think is really good. When you're trying to clean out your closet, you open the closet and you take everything down and then you organize. These are all my shirts, these are all my pens, these are all my shoes. Really, it starts by doing an inventory of what you have. So you try to make an inventory, and then you start to see natural clusters happening. And then you try to see, are there horizontal traits that you can take across these items. In the example of clothing, you have pants, you have shirts, you have shoes, but you could potentially take color as an access. You can take potentially, a beautiful day as an access, or things like that. And so you start to do that field that you're tackling. And I like to see a system evolve. At one point, you do have to get a little bit more technical again, and you say, all right, I'm writing design rules. They are not going to be perfect. They're not going to be covering everything, but it's okay sometimes for the design system to be a little approximative, because it serves the whole.
Makes a lot of sense. So there are a couple of other really interesting questions here. The first is from Larry, and Larry asks, at what age did you actually realize that you wanted to go into this creative direction? Did you strike on your own, or did you have a group of friends involved in the creative process? You know, who were your mentors? How did that look like when you were a young student, just kind of embarking on this journey?
Every time I think I've pinpointed a moment, I then find moments that are prior to that. So I don't know if I have a very good answer to that. I do know I grew up in a very supportive household. I have 3 sisters, no brothers. My parents were very, very supportive of our academic and career endeavors. My mom has always been a career woman, and seeing her as a role model had a big influence on how I saw myself in the world. My dad was very supportive of us kind of following our passions, and that was really important. I was also a troublemaker always. I was always trying to break rules and change things. And I got into a little trouble, but not a lot of trouble. I mean, I didn't do like really bad things, but I think, having an environment that allows you to fail, it allows you to kind of stretch, push the boundaries a little bit, I think is important. But this entrepreneurial drive, I do feel like I've always had it, but I only developed the confidence to do it after engineering school. I almost felt like I needed the engineering foundation, a little bit, relating to the question that came about the imposter syndrome, a little bit because of that. I almost felt like I needed the credentials to be able to then kind of break out of it. And so I did my engineering degree. I wasn't very good, by the way. I was almost failing out of engineering. I was really bottom of the class in my undergrad because I was so bored out of my mind doing it. But I felt like, okay, I have this foundation. Now I could do something more creative. I started to think about engineering and art, engineering and design, engineering and entrepreneurship. And then it became a little bit more empowering than it was before.
I just have this mental image of you as a 10-year-old kind of breaking the television and trying to figure out what happened.
And then running away being like, it's not me.
Yeah, I didn't do it. It was my sister. I didn't.
Absolutely, yeah.
Hey, Todd asks a really interesting question. Todd asks, what is your opinion on high school and college age students who rely on technology, that is something like calculators or computers, to solve math problems, but they don't really understand the concepts of math, or they have the inability to solve math problems without technology?
I think the question, I maybe would approach this question a little differently, and I would say, is their relationship with technology a relationship of consumption, or is it a relationship of creativity and creation? If their relationship with technology is to just consume facts, then I think that's not healthy. I think we lose our agency as humans. We lose our power, if you like, over technology and over the world. And I don't think that's good. But I think that if you are using calculators and software, et cetera, to solve math problems, but it's because the math problem is a means to an end to be able to build something sophisticated, or to make a robot, or to come up with a new idea, or to really kind of rise up at this level of abstraction, then I think that's a much, much healthier relationship. I think if you think about littleBits, we're actually not teaching the very, very low level electrical engineering concepts. We are not teaching transistors and capacitors and current. We are teaching interaction level electronics, light, sound, sensors, switches, So you are one level above that, and still you can do a lot of creativity with it. So I think it's more questioning, what is it, a laziness? Is it just wanting the solutions to come to you? Or is it because you're trying to reach a higher order and to do something that's a little bit more creative, more sophisticated, or more intersectional with other fields?
That's a fascinating answer. I appreciate that. We have another question here that I'd like to read to you from Nichelle. And Nichelle asks, what kind of collaborators do you work with? And how can future STEM students prepare themselves to tackle some of the questions that you've posed about understanding our world better?
I love collaboration. I'm really inspired by curious and creative people of all backgrounds and interests. I've done a lot of collaborations with engineers, with designers. Design is something that's really important. I think engineers don't often respect design enough as a method of thinking, as a profession, and as an equal sort of partner in thought process. So I love collaborating with designers. But also I've collaborated with political activists. I've collaborated with psychologists. I've collaborated with business people. I think really the thing I look for is more a personality trait, curiosity, agency, and a certain level of optimism that there is a problem, but I'm more interested in finding a solution to it than I am listing all the reasons it's a problem. So it's a little bit more around the personality trait than it is around the field they come from. And honestly, the world we're living in, we're noticing people going back and forth between fields so comfortably. You study engineering and then suddenly you become a business leader, or you study design and suddenly you're the CEO of, the CEO of Airbnb is designer. You're a fashion designer, then you suddenly become a scientist interested in how to integrate, biology into clothing. The fields are very fluid. So I think it's important to think more about the types of problems you're interested in solving in the world, and acquiring the skills you need at that point, or working with people that can help you get there.
Excellent. We just have time for one or two more questions. I'm going to try to go through some of these quick. Kathy asks, she says, "Hi, Ayah. I love these ideas. In your opinion, are there limits to modularity? And if there are, how can you work around them?"
There are limits to modularity. I think that knowing what you're using modularity to achieve is important in helping you accept the limits. So for example, let's take the Lego example that I always go back to. There's only a certain resolution you can achieve with the things you make with Lego. You are not going to be able to do a very fine-grained, very high resolution structure. That's just the constraint of Lego. At one point, you want to create a really, smooth, shiny bridge that has curves and goes up and down. You're going to have to get out of Lego and use a more kind of additive manufacturing tool, a 3D printer, a mold, etc., something else. With littleBits, you have similar limitations. There are certain really, really complex pieces of technology that we couldn't create because it would just require too many modules. So, I once challenged our team to create a computer out of littleBits, and we calculated how many bits it would take, and it was multiple football fields worth of modules. So that's, a space constraint, it's a cost constraint, it's also a complexity constraint. At one point, you don't even know where you started. So there are definitely limitations. I think you think of modularity a little bit as a stepping stone. It's a way to prototype, it's a way to understand, it's a way to learn, it's a way to collaborate with someone else. It's a way to, I'll say prototype again, just because you prototype and you iterate. That's what it does really well. Of course, modularity is used in fields like shipping or construction. That's not about prototyping. That's very scalable. But they're using it for a different purpose. In that case, it's more about standardization. It's more about kind of reducing costs and things like that. So I do think, yes, there are limitations, but you can get very, very far with using it for breaking down, learning, reinventing, you can get really, really far. And then you can maybe transition to another modular system that might be a little bit more suited for the next phase.
So we have time for just one more question, and if you just had a minute with someone in a young girl in a STEM career, what would your advice be to that young student?
My advice would be. I think that don't be afraid to fail. Just don't be afraid to fail. Try lots of things, fail at a bunch of them, try again. Unfortunately, many people grow up in environments or families or with social constraints where they are not able to fail. But I think, trying to do it within the means that they can is important, but also most importantly, not letting failure tied to your sense of self-worth, I think is even more important. So I would say, I would tell her, you have something you're interested in, research it, read about it, learn it. You have an idea of something you want to make it, sketch it, make it with any material that you see in front of you. You have somebody that you want to meet, try to figure out if, you can watch things about them or figure out somebody to introduce you. Just like, don't be afraid to try things out. And if many doors do close in front of you, which they will, it doesn't mean that it's you. It means that method didn't work, and so switch to another method.
Well, Ayah Bdeir, it has been a real pleasure to have you with us tonight. Thank you so very much for sharing your perspectives and your experience with us, and also for being a trailblazer in science. We appreciate your joining us tonight.
Thank you so much for having me.
Folks, I'd like to once again thank our lecture series sponsors, the R. Harold Burton Foundation, the Cultural Vision Fund, Rio Tinto Kennecott, the Clark Foundation, the DeFiore Foundation, the M. Lazy M Foundation, the Nature Conservancy in Utah, Ruth Novak, and Frog Bench Farms. Please join us next Thursday, a week from now, for our evening with Dr. Nalini Nadkarni, and the following Thursday, April 22nd, for our keynote speaker, Dr. Mae Jamison. As we bid you good evening tonight, I'd like to remind you of just a few exciting things that we've got going on here at the museum. The museum's open 7 days a week from 10 to 5 p.m., 10 a.m. to 5 p.m., and also late Wednesday evenings until 9 p.m. We require advanced reservations for tickets, and you can get those tickets on our website, nhmu.utah.edu. Please note that we do have more availability through Monday through Thursdays rather than the weekends. April is Citizen Science Month. Learn more about our website, learn more on our website about how you can participate in science. Citizen Science Month culminates with the City Nature Challenge, April 30th through May 3rd, which is an annual international contest that encourages people to find and photograph plants and wildlife where they live. The Natural History Museum of Utah is very excited to open our next special exhibit to the public on May 20th, Egypt, the Time of Pharaohs. And it's an event that will transport you back in time 5,000 years to an age when pharaohs ruled, pyramids were built, and art and culture were prized. Be sure to visit that website for more details. That's nhmu.utah.edu. More details on those programs and other events that we've got going on. Thanks so much for joining us, and we'll see you next week.